Good day, students. This is Helizchem, and today we want to continue with the topic factors affecting preferential discharge of ions during electrolysis. This will be the part 3 and the concluding part of this topic. What are the factors affecting discharge of ions? 1. Position of ions in the electrochemical series. 2. Concentration of ions in the electrolytes. 3. Nature of electrodes. If you look at my channel, you will discover that I have explained the position of ions in the electrochemical series as it affects preferential discharge of ions during electrolysis. That is the part 1 of the video. 2. Concentration of ions also, I have explained that in the part 2 of this topic. Today, I want to go into nature of electrodes. How does nature of electrodes affect preferential discharge of ions during electrolysis? Nature of electrodes. Nature of electrodes can be discussed under 3 approaches. 1. Inert electrode. 2. Electrodes that are having strong affinity for certain ions in the solution. And 3. Electrodes that possess certain properties similar to those of the ions in the electrolytes. Let me start with inert electrode. Some electrodes will not take part in the electrolytic reactions. Some electrodes do not take part in the electrolytic reactions. Hence, this type of electrodes are known as inert electrode. An example of such electrodes are platinum and carbon. This carbon that we are talking about is carbon in form of graphite, because we all know that carbon has 2 crystalline allotropes, which are graphite and diamond. So it's only graphite that can conduct electricity. So when you use this type of electrodes that are inert, they are not chemically reactive. They will not take part in the electrolytic reaction. However, platinum is attracted by liberated chlorine, while carbon is also attracted by liberated oxygen. Those are the few exceptions that we have. So when you use electrodes that are inert, they have a way of affecting preferential discharge of ions during electrolysis. For example, if you look at the part 2 of the video, you will see where I use example of electrolysis of concentrated sodium chloride. In that example, we are using inert electrode. For example, platinum. We used platinum electrode, and you will see that the type of ions that are discharged at the cathode is quite different from the type of ions that will be discharged if you use another type of electrode. That is that with inert electrode. B, that is using electrode with strong affinity for certain ions. We have some electrodes that have strong affinities for certain ions in solution. And as I'm discussing that, I want to use a particular example. Let us look at electrolysis of aqueous sodium chloride using platinum electrode. Electrolysis of what? Aqueous sodium chloride using platinum electrode. During this electrolysis, we all know that this is sodium chloride. The ions is aqueous. We have sodium, we have chloride. Then from water, as we all know, there will be H plus and what? OH minus. We have these four ions in solution. We have these four ions in solution, and don't forget that we are using platinum electrode. If you use platinum electrode, at the cathode, we have these two ions being migrated to the cathode, but hydrogen ions will be discharged. Why? Because hydrogen ions are lower in the what? In the electrochemical series. Hydrogen ions will be discharged. But now, what about if mercury cathode is used? If mercury cathode is used, we have these two ions, like I said, sodium ions and hydroxide ion at the cathode. So if we have mercury has strong affinity for sodium. So instead of hydrogen ions to be discharged, mercury will quickly get attracted to sodium, and they are going to form what we call sodium amalgam. What did I call it? Sodium amalgam. Because it's taking a lesser energy for that to occur. Sodium will quickly attract mercury, or let me say mercury will quickly attract sodium ion, and they will form sodium amalgam. So instead of hydrogen ions to be discharged, sodium amalgam will be discharged because it takes a lesser energy to do that. And this is because this mercury has strong affinity for sodium ions in solution. Now, let's go to the C aspect. C aspect says we have some electrodes that possess certain properties that are similar to those of the ions in solution. And we can see this in the electrolysis of copper 2 tetrasulfate 6 using copper anode. Electrolysis of copper 2 sulfate aqueous using what? Copper anode. In this electrolysis, we have the following ions From copper 2 sulfate, we have Cu2 plus this is aqueous plus sulfate 2 minus aqueous, and also from water, which is liquid, we have hydrogen aqueous plus OH minus. So we have these 4 ions in solution, but we want to look at the anode. These 2 ions migrate to the anode. On getting to the anode, none of these ions will be discharged. Why? This is because we have copper anode, and this copper anode is having a similar property to those ions in the electrolytes. Don't forget, we have copper 2 ions, hydrogen ions, tetrasulfate 6 ion, and hydroxide ions, all present in the electrolyte, and we are making use of copper. So what copper will do now? Copper will quickly dissolve. It will go into solution by losing what? Electron, to become copper 2 ions. When it becomes copper 2 ions, it will get attracted to the copper ions in solution. It will go and meet the copper ions in solution, and they will join together. They will get deposited at the cathode. This is so because copper anode, which is the electrode, is having a similar what? A similar property to copper 2 ions in the electrolyte. And that is why you will see that this hydroxide ion will not be discharged. Sulfate ion also will not be discharged. Is that taken? But rather, the copper anode will dissolve by losing what? Electrons to form copper 2 ions, and they will come together with the copper 2 ions already in solution, get attracted to the cathode, and they will be deposited. So this is what we are saying when we are talking about electrodes that possess similar or that possess certain similar properties with ions in the electrolyte, because it requires what? It requires a lesser energy to do that. And when you look at this particular example, this is the principle used in the extraction and purification of some metals. Stay tuned in my next video as I'll be discussing on that, extraction and purification of metals using electrolysis. I hope you are blessed with this topic. I want you to stay tuned on the same channel, Helizchem, share, like, and subscribe to my YouTube channel as well. Until next class, where I'll be bringing you more insightful topics in chemistry. Bye.